This is Dr. T. Ramya, Assistant Professor, Department of Physics, Chevalier T. Thomas Elizabeth College for Women. In this video, we are going to discuss about quantum mechanical model. In 1926, Erwin Schrödinger took Bohr atom model one step further. According to this model, an atom consists of a dense nucleus that consists of proton and neutrons. These protons and neutrons are surrounded by electrons that exist in different clouds at various energy levels. Schrödinger theorized that the behavior of electrons in atoms could be explained by treating them mathematically as matter waves. Thus, the quantum mechanical model is based on quantum theory, which is the theoretical basis of modern physics that explains the nature and behavior of matter and energy on the atomic and subatomic level. So, the quantum mechanical model was explained on the basis of three concepts: wave-particle duality, uncertainty principle, and exclusion principle. Wave-particle duality. So, it is the exhibition of both wave-like and particle-like properties by a single entity. Planck and Einstein's work showed that light waves exhibit particle-like properties. Later, Louis de Broglie hypothesized that particle could also have wave-like properties. According to de Broglie, the wavelength expression is given by lambda is equal to h by mv, where h is the Planck's constant. Heisenberg's uncertainty principle. In 1927, Werner Heisenberg stated that the position and velocity of an object cannot both be measured exactly at the same time, even in theory. The very concept of exact position and exact velocity together, in fact, have no meaning in nature. The uncertainty principle is alternatively expressed in terms of a particle's momentum and position. The momentum of the particle is equal to the product of its mass times its velocity. Thus, the product of the uncertainties in the momentum and position of a particle equals h by 4 pi or more. The principle applies to other relation pairs such as energy and time. The same relation holds for unstable atom. Uncertainty between quantity of energy radiated and the uncertainty in the lifetime of the unstable system as it makes a transition to a more stable state. Coming back to quantum mechanical model, atoms uses complex shapes of orbitals called electron clouds, in which there is likely to be an electron. So this model is based on probability rather than certainty. The probability of finding the electron is greatest, and conversely, the electron is less likely to be in a less dense area of the cloud. Thus, this model introduced the concepts of sub-energy levels. 4 numbers called quantum numbers were introduced to describe the characteristics of electron and their orbits. Exclusion principle or Pauli's exclusion principle, which states no two electrons in an atom exist in the same 4 quantum state. The state is determined by 4 quantum numbers, namely principal quantum number, orbital angular quantum number, magnetic orbital quantum number, and magnetic spin quantum number. Coming to principal quantum number, it is symbolized by n. It is the first in a set of 4 quantum numbers used in quantum mechanics to describe the atomic orbital or the arrangement of electrons around a nucleus, which represents the overall energy level or size of the orbital called as the shell. Higher the number, larger the region. The values it can take are n is equal to 1, 2, 3, 4, etc. Orbital angular quantum number, which is represented by L. This describes the shape of the orbital, and the shape is limited by the principal quantum number. L can have positive integer values from 0 to n minus 1. Orbitals that have the same value of n but different values of L are called subshells. Magnetic orbital quantum number, represented by m suffix L. This describes how the various orbitals are oriented in space. The value of this number depends on the value of L. The allowed values are from plus L to minus L. For example, if L takes the value of 1, then ML will take the value of minus 1, 0 and plus 1. This means there are 3 different p subshells for a particular orbital. The subshells have the same energy but different orientation in space. The last number is magnetic spin quantum number, represented by m suffix s. This describes the direction of electron spinning in a magnetic field, either clockwise or anti-clockwise. The allowed values are plus half or minus half. So all these numbers were derived from the Schrödinger equations, and you can see the shapes of 1s, 2s, 2px, 2py, 2pz atomic orbitals. Coming to the outline of quantum mechanical model, electrons are not described as a point source, but they travel around the nucleus and they form waves as standing waves. Standing waves are nothing but a vibration of a system in which some particular points remain fixed while others between them vibrates with maximum amplitude. The amount of movement of the wave gives the probability of the electron at a particular location, with the electron acting as a cloud within the region defined by the standing waves. These are the outlines of quantum mechanical model. Thank you for watching my video.